Hello everyone. This is the second day of our triangle similarity proof section. Yesterday we did the side splitter, so if you missed that, make sure you go back and do that one first. This is the one we did on the block day, either March 28th or March 29th, depending on what day you were in class. For 2017 at least. For being used for other years, don't know what day it is. So if things are similar, oops, guess I should actually have some markers here. If things are similar, remember that doesn't mean that they're exactly the same shape. In fact, it means that they're the same shape, oopsies, but different sizes, okay? So think about maybe we have a tiny little triangle and then we tripled or quadrupled its size and got a big triangle. What that means is that we're going to have proportional sides, which means that the sides might be double or triple or quadruple the sides, but the angles are going to be congruent. Now, some of you might be thinking, well, why aren't the angles proportional too? If we're doubling and tripling everything, shouldn't it do that to the angles as well? All right, well, think about our triangle. If I have a 30 degree, a 60 degree, and a 90 degree, and I double or quadruple that size, let's say we double it and we get a 60, a 120, and a 180. Do you remember the rules that we had for angles in a triangle? What did they all have to add up to? 180. Well, obviously we have an issue because one of the angles alone is 180. So that scenario cannot work. They have to be congruent, which means equal. So if I double or triple the size of the triangle, it's not going to go from 30 to 60, it's going to stay 30. It's not going to go from 60 to 120, it's going to stay 60. And then still 90, so that it still adds up to 180. Last week you guys talked about the first of our three quote-unquote cheats for triangle similarity. If two angles and two triangles are the same, then they're automatically similar. The other two we're going to talk about today are SSS, which you can probably guess stands for side, 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 and SAS, which is side, angle, side. So make sure you get that part copied before we move on to the next piece. First section, side, side, side. If the corresponding sides of two triangles are proportional, again, there's that word proportional, they're not congruent. Here's our proportion, right? Proportions are just fraction equals fraction. In this case, fraction equals fraction equals fraction, because there's three sides, three triangles. Then they are automatically similar. Don't even care what the angles are, they're automatically going to be similar. Okay? And similarity is pretty important. We use it in a lot of different things. If you guys have ever played the game Mario, or any game that has the character Mario, when he gets that red mushroom, he grows in size, right? That's a similar character. Okay, the original Mario is a smaller one, and then he gets bigger, but it doesn't make him a different looking Mario. He's just bigger, okay? It's not like he loses his shape or he looks really weird. It's just that he's a different size. That's similarity. So let's take a look at our first example. In your notes, you'll notice it says that we're trying to see if they are similar. So are they similar, first of all? If they are, we're going to need to write a statement, a similarity statement. And we also have to put down scale factor. Lots of stuff to do. And it says from triangle B to triangle A. All right, well, if it's from B to A, which one's the old one? Obviously, that means B is old, A is new. So make sure to mark that on your paper before we move on. Old to new. It's going to be important for our scale factor, because scale factor is always, new over old. It's always going to be that. Okay, so let's mark out our ratios then. Okay. It's pretty easy to tell what goes with what. Make sure it's new over old, so we have 6 over 12. And that goes, let's see, we're going to actually ignore these guys. Let's put that back up. We're going to do 12 over 6. And then new over old, 10 over 5, and 8 over 4. Now again, the reason I'm doing it this specific way is because it's new over old. New over old. You got to keep it consistent. So make sure you're not doing 4 over 8, 5 over 10, 6 over 12. Those are matched correctly, but they're not the correct formula for scale factor. So let's check. 12 divided by 6 actually comes out to a nice number. It's 2. 10 over 5 comes out to 2, and 8 over 4 comes out to 2. Awesome. So I figured out that yes, they are similar. My similarity statement then would be triangle PQR is similar to triangle STU. Make sure we match up those letters appropriately. And then last but not least, we just figured out the scale factor. It's 2. That means the picture was doubled to get to the new one. All right, so similar by SSS, all the sides are proportional. That means the whole thing is similar, which means all their angles are going to be congruent because we just talked about that. Okay, so here's the directions for the second one. I know it doesn't actually say it on your worksheet, so make sure you understand that that's what it's asking. Is either triangle GHJ or DEF similar to triangle ABC? That automatically means that this one is our old guy. I'm going to mark that with the number 1. And then basically we're doing 2 things. We're comparing it to the second triangle. So we'll call this new option A. And this guy is new option B. All right, so a couple choices to look at to see which ones are actually similar or not. All right, so I'm going to have to set up a couple proportions. So let's do the first one compared to the second one. I'm going to have 3 fractions because I have 3 sides to my triangle. Pause here, see if you can set it up yourself. Test it out, see how you do. And then you can press play and see what the answer actually is. Make sure you're setting up new over old. It's important that you keep that same process, all right? Don't switch it up. All right, pause here, try it on your own. Do not just copy what I do, at least attempt it on your own. All right, so even though these triangles look like they're pretty well matched up, I'm actually going to use something to make sure. All right, if I look at my numbers, I need to match up the biggest with the biggest, the medium side with the medium side, and the smallest side with the smallest side. Well, in my new triangle, the biggest side is 14. In my old triangle, the biggest side is 12, so it's going to be 14 over 12. The medium-sized triangle in my new is 10, and the medium-sized side in my triangle is 9. So we get 10 over 9, and then obviously that leaves us with 6 and 6. Okay, and I know that one was pretty easy to tell where the sides are, but once you get to this guy over here, it's not going to be so easy. So use that trick again, comparing large side versus large, medium versus medium, so on and so forth. All right, so let's figure out our scale factors of each. If you do your calculations, just 14 divided by 12, I believe you get 1.6 repeating. For 10 over 9, you get 1.1 repeating, so I'm just rounding off. And 6 over 6, oops, you get 1. Obviously, these are not equal to each other, okay, which means that these are not similar. Okay, so as soon as you get different scale factors, automatically means you're done. They can't be similar. They got to have the same scale factors if we're going to be comparing them properly. All right, so jump over to the other one. Let's compare 1 to triangle 3. Again, set up your 3 fractions. Again, pause here. I really do want you to pause for this one and try it on your own, especially because this is not an easy picture to figure out where everything is. Okay, So again, look for your biggest side. Compare it to the biggest side over here. Look for your medium side. Compare it to the medium side over here. Pause, please, and try it on your own before you listen to the rest. All right, largest side is 8. Largest side in the old one, 12. So 8 over 12. Medium side is 6. Medium side, 9. So 6 over 9. And, whoops. And we have 4, which is the smallest. 6, which is the smallest. All right. So now you can either do like what I did in the first one, which is divide, which is a great way to do it, or you can also just reduce to the simplest fraction. I'm going to do the dividing route just to be consistent, but you could also reduce and get the same answer. So 8 over 12, when I type that in, I get 0.6 repeating, so I'm going to round it to 6, 7. Type in 6 over 9, also get 0.6 repeating. And 4 over 6, let's just double check. Also get 0.67 repeating. Okay, and actually if you reduced all these down, you would find that it's actually the fraction 2/3, which is great because it keeps it a nice, good looking fraction. The decimal is kind of messy looking, especially with the repeating, so it might not be a bad idea to put it as a fraction instead. All right, well, since they are all having the same scale factor, this is a yes. It's similar, and we need to be specific. It's similar by SSS, okay, because we're doing side, side, side. And I need to actually say the triangles. So we've got ABC, similar to, let's just double check, DEF. You do have to say this statement. Think of it like the concluding paragraph of your 5-paragraph essay. You got to sum everything up that you've supported, tried to explain in this statement. That's your concluding statement. All right, moving on. Now we're on to side, angle, side. Please pause here, copy this down. Pretty self-explanatory, right? Side, angle, side. Got to have 2 angles that are congruent. That's these guys right here. And you have to have 2 sides that are proportional, not congruent. Think of it like a little Pac-Man symbol. This is the mouth of the Pac-Man. You know, in that video game where he's got the little dots that he eats. And this is our giant Pac-Man symbol. You can't use this side, okay? You got to use the mouth of the Pac-Man. If you're going to use this angle, you got to use the mouth. Same thing here. These are the sides that I have to use with this angle. Think of the big Pac-Man eating everything. That was really bad looking, but you get the idea. All right, so let's take a look here. Pretty easy to tell we've got some congruent angles. Angle C is obviously congruent to angle F. Yes, you need to write that out. Okay, if you even want to write out the word given, wouldn't be a bad idea. And then we only have to write 2 fractions. One for the short sides, one for the long sides. Well, the shorter side here is 3. We're not worried about scale factor, so I'm not really comparing new versus old. And it doesn't tell me, so I'm just going to do 3. And that matches up with the smaller side in the second one, which is 5. And then we've got the larger side over here compared to the larger side over here. All right, good. If I divide both of them, let's make sure they actually come out to good fractions. I get 0.6. I get 0.6 here. Awesome. Okay. That means that, yes, they are similar by SAS this time. And then also make sure to write your similarity statement. See if you can do that solo. Last one, my biggest hint with this guy is you need to write it out separately. That means draw those triangles out individually. The reason I say that is because some of you might think, oh, these are pretty easy to figure out. I've got V, Y, Z here. Then I put 8 and 10, right? Those are the sides of my triangle. Wrong. It's got to be the whole side length, so make sure you don't put 8. Make sure you put 12 Make sure you put 15 here. See if you can figure that one out solo.